Okay, so here we are finding and interpreting a correlation coefficient for a situation. And we did do a scatter plot for this in another video. So I hope that you can check that for the visual of what this looks like on a scatter plot. And from what we looked at, it looked like it was like a strong positive linear correlation. And so let's see if the correlation coefficient like goes along with that, okay? So a pediatric nurse marks down the ages and heights of all the female patients she sees in a day. If you guys remember, or if you check that video, which I hope you do, we did let our ages be our X values, our independent, and the height Y. And we put our X's in L1 and our heights in L2. And we want to find the correlation coefficient, and then we'll determine if it's positive or negative, if it's strong or weak. And then I want to maybe go in a little more detail regarding that. So let's go to our calculator. So again, stacked test, Linac t-test. You don't need to worry about this right now. Just put it as a not equal to or two-tailed test. Maybe later on you'll determine the type of test and such, but just put your X, your Y, your frequency 1, two-tailed, and then calculate. Now, you don't need all of this right now, at least for this, but there's an arrow pointing down that indicates more information. So when you scroll down, you'll see your R, which is your correlation coefficient. And that is what we want for this particular situation. So my R, my linear correlation coefficient for the sample, right? That's what R is for the sample, is 0.969 basically, right? If we round 969. And obviously that's a positive number. So my correlation is positive. And I'm going to say it's strong. It's a very strong positive linear correlation. And if you look at that, the reason that I say that is because the closer that my correlation coefficient is to +1, the stronger the correlation. And this is just linear correlation, okay? The correlation coefficient R is only a linear correlation coefficient. So it's only measuring the strength of the linear correlation. And again, your correlation coefficient R is limited between -1 and 1. And the closer it is to either end, the closer it is to -1, the stronger the negative correlation, and the closer it is to +1, the stronger the positive correlation. And this, R is equal to 0.969, is very close to +1. So I would say that there, same thing that I did in the other video where I looked at the actual scatter plot, which you can see kind of verifies this. So there is a strong positive linear correlation between between the ages and heights of female patients in this whatever hospital, wherever this pediatric nurse is. Okay. And the reason that I say that it's strong and positive here, which is basically the same thing that I said when I did the actual graph, is because the R, the linear correlation coefficient, this is measuring linear correlation, is close to +1. So it's a positive and it's strong linear correlation.